I built AI generation service using best models from WaveSpeed and Fall AI. So here it is. Here is the architecture. You see, I use Docker, I use virtual private service, I use Nginx, I use WaveSpeed, Fall AI, Telegram API, and bunch of microservices for generation. I used this service for some models and this service for some models. There was a lot of work. So let's just break it down. Let me explain how I did it and what was the results. First of all, it's very hard to explain everything what I've done because I can go very deep inside the architecture, inside libraries, inside all the things. First of all, I used Node.js because I know Node.js and I know all the libraries. For example, for connections for the database, I used really low RAM because I just want to use Postgres database to train, because on the previous project I used MongoDB. So this time, to make it more fun, I used relational database for that. And it worked. I had a lot of migrations, but different migrations for local dev and prod environments. So that's why it was just interesting for me to try it out. Well, what we have here? We have containers. All these microservices are running in the containers. We have Telegram bot server that runs inside basically HONA server in container. Yeah, what else? It aggregates two services and it uses Grabim for interacting with Telegram API. And yeah, it connects to the Postgres database using Drizzle, and it uses actually all the services here is intentional. Why do I need metadata API? Because I need to know the length of video, audio, resolution of images in advance for cost calculation. I have more than 10 cost calculations for each model, and I have to use that data using other microservice that uses Fmpeg utility inside it. So that's why I use this service. Why do I need this content download worker? Because those two services sometimes produce error on content downloaded, when content is downloaded. On the webhook, I got this result from those two APIs. And cannot download their content, audio, video, and so on. I produce message in the Redis for content download worker that will download this heavy media, upload it to GCP buckets, and send back the message through the Redis to Telegram bot server. For this, I use BallenQ because it's easy to set up. Also, I catch every error in my system using glitchtip. Why glitchtip? Because it has centric connections, and glitchtip is free. I don't have to pay. For all these things, I pay only for virtual private service that I actually use in use Hetzner. This is all my logs. You see, I don't pay for that. All my issues and other things that I can set up. But I don't pay for that. I'm enough. Okay, and I deploy it using Docker directly on virtual private service. I use Nginx for a load balancer and for exposing, for mapping to domain names. Yeah. Each of my services mapped through the Nginx to domain name. And that's basically it. That's how the system works, like briefly. The main question, how I was able to aggregate that many models in one server. That's pretty difficult thing, because I changed the shape of data that I got from those two services. For example, I have this model, image to video, and I have this schema that is there is the button. When I click it, I see the schema of the model and all the required properties like prompt, image, aspect ratio, resolution, and so on, and other properties. Also, I have the same thing for Nano Banana in another service. Like here, see, I can pretty print and also have this shape of data that should be collected, like each property. Like here, we have prompt, aspect ratio, images, different images, and so on, resolution, and even more. And what I did is change the shape of data to what I need in my required shape of data. I include only required properties for me. For example, in this particular example, we have schema for Sirius 2.0 image to video turbo. We have endpoint ID that I use to identify, just to identify this model. Then I use display name to show it inside the bot. Category, that's basically category that I use here for sorting. Also, I have description. Maybe in the future I will add it. Then I have flow step. Each flow step is what the bot will require from us. So in this example, let's show for example for Sirens. This is the first step. This is here. You see, here is the prompt. It's the first step. Its order is 0, and here we have it. Here we have the prompt, and we, for example, when we enter dancing girl here, we click enter, and another step is image. And here we see image. Its key is image, and our Telegram bot is expect image to be sent. If I send something else, it will require us image. So we have validation here. And also another interesting thing. So it requires image from us, and so on. After image, it will require like last image. Also, I don't know, some properties could be required, and some properties is not required. Also, I have aspect ratio and all the kind of stuff. After the data is calculated, yeah, let's just see as an example. Let's attach image here. Then we have the last image we can skip. Then we can choose resolution. Then we can choose the duration, aspect ratio. Let's generate audio, and see here we see all the data that we calculated. It's not easy to even show that kind of data that you see here. And when we click generate, the data is calculated in advance. We have this pricing calculation. So I have a lot of pricing calculations, and for that one I use per second with the resolution as an audio. And if we have resolution 720, we have different prices for each second. And yeah, and those I have a lot of strategies for each model, and this is only the one. It will take a lot of time to show all the strategies. And as you can see here, yeah, the price is calculated. If I click pay, generation will start eventually, and this is it. Yeah, and the same will be happening for Nano Banana. I can click cancel here. I can go back, and I can go to text to image and choose Nano Banana. I can click the same prompt, dancing car, let it be. Then I can choose aspect ratio, resolution, number of images. I can click get generate, and if I click generate, also the same. Generation will eventually happen, and that's it basically. Yeah, I like hard-coded each model in JSON in my required shape, and after that I will able to process. I create a special engine that processes this shape of data with Telegram, and it's not easy because currently it's scalable. I have different keys, like here you see prompt, you see image, and Telegram type for that is photo. Here it's photo, the same. Here is text, because we have different handlers for text, photo, audio, video, and files, and even general handler. And all the stuff is based on that handlers, that processes, and have the shared generic algorithm for processing each step. So currently, it's scalable. How I was able to implement that thing inside like Telegram? It was very hard because first of all I have to know how Telegram works, what data it processes, like all that stuff. And first of all I didn't know that, and I only know how it could be shown. And I tried just draw the each step inside Figma. So first step, like initial menu, we have different categories. I didn't implement preview next button, but I can implement it in the future. So I have different model categories. Like here is the same, just to show it out. Then I have different type of oh no, it's I mean category like text to image and audio to video, like we see here. This one menu category. And if we click, for example, to image to video here, we see here different models. Model name, just forgot to change it to model, some kind of number. Yeah, and we have different numbers. We have go back button also. And after that, we have different type of data collection. We can be asked to send a prompt. We can be asked to send a menu, to select aspect ratio, resolution, audio, and so on. And all that things is I was thinking in advance for all those things, for different type of images. Each image is actually processed sequentially because Telegram processes each message individually, so I have to group them, have to know that if, for example, I have multiple images, I have to absorb all of them. Interesting was to implement it. I used middleware, and also I have step for video collection. And after that, what happens next? Let's go by ours. I can have a multi-prompt. Multi-prompt is that thing when you have, for example, prompt inside prompt. It actually used inside Cling. Let we see here as an example. Let's go to image to video and choose Cling. Maybe here. Okay, I found it. You see, we have steps and we have special property and telegram type nested array. We have children that processes each step inside this property children, and the bot processes that step. Here you see how I think it in advance. I can have a multi-prompt and with the same data collection elements inside that step, inside that flow, to collect different type of things like image, aspect ratio, and so on. And then I can add another element, so I can click add another element. Also I have the max number of that inner elements that I can add, but that's basically it. That's basically how I add inner elements. Okay, and after that all the data is collected, and here we go with the price calculation. On this step we have like different pricing strategies. Pricing data is pulled from this JSON schema and it's calculated. After that the price is shown in stars. We can click confirm and pay, and after that we have our generation, and that's it. That's how I did it, and designed these screens in advance and then implement. That's basically very enjoying to draw the design in advance and then implement it. It's very enjoying. Yeah, all the things here is working as expected. You see this green square generated content, and I have it in my Telegram bot. It's very enjoying to implement all these things. Amazing, guys. Like, you can imagine something, then create the design and then implement that idea. You feel amazing after that. Believe me, feel amazing. It took me about, I don't know, maybe 2 months or even 2.5 months to implement all that things, because they have to debug it. Oh, yeah, of course I did it with AIs. I wouldn't be able to do this without AIs. And I show you only small things of whole architecture, because there are a lot of things that building in that bot. The last thing that I want to show you guys is schemas for generation. As you can see, there are a lot of steps inside generation process. I have a lot of if-else condition and control flow statements and interaction between different parts of the application. It may even take very long to explain all those things, because it's production ready application with a lot of inner steps, with a lot of validations, with a lot of side logic, because a lot of things could happen during generation, and application should be ready to react on that things and to have the data generated for the user, because it's very important. As you can see, I can even zoom in this thing correctly to show you all that stuff. Let's just review a flowchart of the generation decision. So first of all, actually it's generated by AI, but I can explain it. It's kinda true. After successful payment, we have entity stored inside our database. Then we have payment entity created inside our database. Then we choose provider. So it basically selects it either can be selected to Fall AI, webhook, Fall AI, API, or wave speed. And webhook is set if the data is sent to Fall AI or appropriately for webhook, wave speed. Then we have stored our request with status processing. Then we wait for our webhook. We have webhook processing. So this basically two services, Fall AI or wave speed, sends request to our service. And we have webhook endpoint, and we have data validation. If the data is not valid, we return 400 status code. And if the data is correct, we have two things. If everything is successful, data is generated, we have the output inside our body of the webhook, we can proceed with delivery to the user. If not, we mark it as failed. It can happen, for example, if the user tried to generate something explicit or forbidden content. We may get errors inside our webhook, and we return refund of the stars that user paid and edit our entity as refunded and store everything in the database. This is the end of that kind of stuff. And if everything is okay, we try to deliver successful message to the user. If we was able to download the content from our provider during 3 times of try, yeah, because maybe the first time could result in error when you download, like fetching the content from their CDNs. It may result successfully, but there was cases when the data was not downloaded successfully during generation. If happening so, I produce that message to external content download microservice that we have actually here through the Redis. And if everything goes successfully, I can download it, we can mark as successful and show it to the user and show the next menu. And let's go this way. Data is published to Balance queue, then content download worker picks that data and downloads media and uploads to GCP. Then content publishes the result. It consumes result. Then if everything is completed, we send media from GCP to our end user. If no, we mark it as completed and refund everything. So basically that's how the thing is working.